Yes, got it. Hello? Test. One, two, three. Hello? Perfect. Yeah, thank you guys for testing. Love the waiting room. Thanks. Just need aid. So, this is Understanding Bitcoin Source number 14. And today I'm talking about Chainstate and UTXOs. So, does anyone know what a Chainstate is? Or maybe what's referring to in the code?
Jerry, you're definitely in
Hmm?
view of the camera.
Oh, no, he wasn't. He was actually like behind my.
you.
Yeah.
I'm just letting you know.
Yeah,
Oh, okay.
You are now.
Yeah.
Chainstate. Are we talking about like where the money is according to like all the different key pairs and like what the state of
Yeah.
balances, if you will, or UTXO values?
It is something related to the UTXO set. It has something to do with information about the chain.
Right.
And
This key pair or this key can sign this much, and like that's the state, or is that not chain state?
that's part of the state. That's not the complete chain state.
That's a component.
Yeah. It's more of a programming concept within the Bitcoin Core code base, but I think it's important to go over it to understand what UTXOs are in the code and how they're used. And I actually forgot to put more context about UTXOs and things like that, but I got a question last time of what UTXOs are. So for anyone watching the stream or anywhere else, UTXO is unspent transaction outputs of a Bitcoin transaction. So if I spend to the pseudonym right next to me called Flaccid Banana, then he, well, like the.
It's a little too on the nose, but.
Yeah, if I spend a Flaccid Banana,
FB.
yeah, all the transactions that have inputs and outputs. And if I spend to Flaccid Banana, he now has an output that he can spend whenever he's ready to. It kind of sits on chain until he wants to spend it. Oh, did not mean to switch there. I didn't mean to switch over here. So let's talk about nodes. Bitcoin nodes. This is the estimated number of reachable nodes on the network as of yesterday or 2 days ago. I forget when I took the screenshot, but recently. And I decided to look over the course of 8 years and see what the growth was. And 222.57% is what was estimated by BitNodes, this website. That's not a crazy number, because if you contextualize it, we can see this is River's estimations. Everyone can just estimate, right? Yeah, we don't know. But if River is estimating 81.7 million to 130.4 million Bitcoin holders, we can clearly see the amount of holders drastically outnumber the amount of Bitcoin nodes that are transmitting in the network transactions and blocks and are validating every person's UTXOs. Do you have a comment, Flaccid Banana?
I mean, it's kind of shocking, these estimates. Like, I'm kind of like, I feel like it seems like a lot of people.
Uh-huh.
That's all. I mean, I'm just shocked.
Oh yeah, a lot of people who hold Bitcoin and
who
don't
hold
run
Bitcoin.
nodes.
I mean, I know it's very few nodes. I didn't realize it was only 20,000, less than 20,000. That's shocking
Yeah.
to me too.
Luke Dash Jr. has his own dashboard where he might add a couple more thousand. I forget what his dashboard says. So this is BitNode's estimate.
It's within that
Are
order
these
of
only
magnitude.
publicly accessible?
No, there's reachable and
like
Yeah, those the reachable nodes here.
So then there's many nodes that are not reachable.
Yeah.
So it could be, is it
Sometimes
does
you have
it
a peer.
double the it's twice amount, or like what, over Tor and like not reachable, or
well,
what
not
makes
even
you
over Tor. Like if you just run a node locally, it can connect to peers, but peers cannot connect to it.
okay, so that would
Yeah.
be what
So
doesn't get into this list.
yeah, so you would just connect to your node over your local area network, and it won't reach anything else.
Right. And sometimes you could have a node that connects to a public node. So you could run two different nodes, Bitcoin Nods and Bitcoin Core, but your Bitcoin Core is the only public one. Or the other way around, I guess would make more
Right, but these
sense
are
for
only
people.
Bitcoin Core nodes.
Yeah. Well, no.
Oh.
There's, I doubt this website is differentiating between different implementations.
Yeah.
Yeah. Estimated Bitcoin holders, as I said. By the way, I think, sorry, let me get something here. Just changing things around on my screen, looking at the chat. Flash of banana, yeah. I see Cypherpunk Radio chatting away. All right, let's go to the next slide. But this slide is pretty interesting. I like River's graphics. I think they had one today. Don't remember what it was about. So the goal with showing these slides was to kind of demonstrate or bring up the issue of the low number of node runners compared to Bitcoin holders. Maybe even discuss whether it's actually an issue. So node runners make up less than 0.01% of Bitcoin holders. That is a very, very small number. You would think it'd be higher with the amount of money that certain individuals put into Bitcoin. The fact that they don't feel a need to validate their own transactions.
Are they even custodying it though? Like how? Like what is the percentage of people custodying their own?
I don't know if the infographic had anything about self-custody.
It kind of did. It just said off exchanges and on exchanges.
Okay, off exchange.
Right.
So how do you use all
So that could still be custodial if I bought a Satoshi.
It said 80% of users hold some BTC in a wallet.
That's still a good number.
Yeah.
They're still not validating the
Well,
blockchain for
well,
themselves.
the reason I asked is
Uh-huh.
because if you're not holding, if you're not self custody, like there is no validating. Like
Uh-huh.
validating doesn't matter at that point because
But if you're not
you don't
running a
know
node,
what your UTXOs are, it's someone else's, right? So it's
but a wallet could lie to you as well, right? Because they're using an API, and their API is connected to their own node, presumably.
yes. But so if you're holding your keys and you're using a wallet and that's not connecting to your own node, then yeah, you're not validating anything at all. But if you're using a custodial wallet, like you can't connect to your own node, you can't validate anything. It's not
Right.
yours. So it's
Right, there's never a way to figure it out. So, unless you send it out to a non-custodial wallet. So I was thinking about the reasons why people don't run nodes. This is what I could come up with. Can you guys come up with any specific reasons? The reasons I came up with: space requirements. Hard drives are only cheap for some. Without the more expressive or expensive SSDs, writes are considerably slower. You have a long sync time. Validation time can take hours or days. It can't start helping the relay network until it's synced. I put an asterisk here because I wanted to discuss that further. It's not technically true. And you have always-on requirements.
I have another one.
Uh-huh.
Most wallets require you to run additional software like Electron,
Mhm.
and it's too much for people to manage.
Yeah, I'd say even the command line can.
I would house that
Yeah.
under what I think is probably a bigger reason why people don't run nodes than all of these things is technical, what would I call it? Technical incapacity?
Yeah.
I don't think Bitcoin
Intimidation, technical intimidation.
Uh-huh.
Bitcoin wasn't written very well to like run very well. I don't think.
Bitcoin Core does not target the average Joe who
Yeah.
just wants to experience new money. They have to be technically advanced to go to bitcoincore.org, find the correct download. If they're on Mac, they have to do some code signing, which Salty Mayo has seen, and it becomes a huge process. So I understand why some people don't want to run nodes, although I do think it's an issue.
I think also the benefit is not like enticing enough to overcome the technical hurdles. So like broadcasting your transactions, getting a first class view of what's going on. Like I think some of them are cool, but like for somebody who doesn't have a background with some of the command, like any of the like more intensive technical stuff, then it's like, oh well, it's not need it. It's not that important to me. I'll just use theirs. Where if there was like some sort of incentive or more compelling, like run a node and you can do X, Y, Z, I think you'd see more. So like there really isn't, other than like, oh, it further decentralizes the network. I can rely on my own. I don't have to, no third parties, and it like, I think that stuff is just not quite, it's not compelling enough for your typical general normal Bitcoin user.
Yeah, I mean, I think even for them to connect whatever wallet they're using to it, like I said, they have to run Bitcoin Core and Electrum and figure out how to, Electrum server or whatever, but
Yeah.
and figure out how to get that routed, whether it's over, so if it's over Tor, they now have to have Tor on their phone and enable it and disable it whenever they're trying to connect to it. If it's not over Tor, they have to figure out static IP addresses or DNS, like DNS stuff. It's just not, it's not built properly for people to run and benefit from, like you said. Like the benefit, it almost seems like altruistic to run it for most people. Is like, I'll just run the node and it's there and it's running, but are they actually validating any of their own stuff on there? Are they actually using it?
Is the game theory good enough for businesses to just run nodes then? And if it is, I feel like we start getting into narrative of the Bitcoin Cash camp or the Bitcoin SV.
I think I'm of the personal opinion that I like SPV wallets, and I don't think that we've done enough with SPV wallets.
Yeah.
It's not a full node, but something.
It's close enough. Well, not really. I think Luge Dash Jr. on Twitter once said it's broken, like that whole scheme.
Well, it's just the miners. So
Yeah.
miners can lie, but it's like all miners have to lie. It's not just like, one service provider is lying to you or something like that. It's like literally, so miners would be able to do some sort of evil fork, and you were just like, cool, everything works.
But I can make the same case for block explorers. All these companies have to lie to me. Blockchain.com, Blockstream, and Mempool.space. Again, is it really enough? Does there need to be more legitimate companies that start scamming people for people to run their own nodes? No, obviously not. But the purpose of the slide was actually to say we should find easier ways to run nodes.
I think we can all agree.
But I wanted to point out this fact that it's a lot harder to run a node for the average individual because desktop, always-on computers aren't very common anymore. We're switching to laptops, we're switching to mobile phones, and these things don't have computations that run in the background all the time. Mobile phones, you have push notifications, but those are periodic. Those aren't very compute heavy, whereas validating transactions, also not super compute heavy, but if you're doing initial block download, then it can be. Or if you get more complex scripts, if you start pushing up against the SIGOPS budget, it's a bit much for phones, especially for background tasks. They do not let you do much with iOS or Android. So accentuated by the switch to mobile. That's the point. Mobile phone usage measured by web traffic. So I took the screenshot from some website that I have associated with this QR code, and the website asserts that even though there's a considerable ownership rate drop, PCs and laptops also lost their shares of web traffic. According to the survey, mobile phones made up 59% of total web traffic last year, showing a 10% jump year over year. On the other hand, laptops and PCs made 38.9% of total web traffic in 2022, or 10.4% less than a year before. So mobile traffic on the web seems to dominate everything else, just to accentuate the point that people are moving to mobile phones more and more and using their laptops and desktop computers to surf the web, which I feel like is a proxy for a lot of other internet applications. So the switch in thinking, why should people run nodes? Going back to this. To make sure, so I guess we've already spoken about why you should run a node, but in the ideal case, what would running a node give to an individual?
Privacy.
Yeah, that's one. I'd say the UTXO set, or figuring out who can spend what Bitcoin, is also super important. So it's to make sure no nonsense state transitions has happened leading up to my current UTXO set, and to make sure no nonsense happens in the future. Right? Because if nonsense happens with the UTXO set, you can inflate the money supply, you could spend someone's coins that you can't cryptographically prove you own, so on and so forth.
So it's like to self-audit the blockchain. Is
Yeah.
To make sure that the blockchain is what it's supposed to be, without relying on someone else telling you so.
Exactly. And maybe if we reframe this question, we could start asking whether a Bitcoin full node needs to preserve the form that it's in. And if there's a happy medium, maybe we can start analyzing what that would be. And I would say the switch in thinking with this has been to find a way to develop a fully validating node without the space and or sync requirements that lessens penalties on offline devices. So this has led to finding ways to quickly validate the UTXO set, which can be used to validate mempool transactions and incoming blocks. And some projects that have tried to bootstrap fully validating nodes that don't have all the blockchain data with them, but have a valid UTXO set and can validate all future transactions are Assume UTXO, Utxos, and ZeroSync.
Now, would these be able to also propagate the mempool?
Yeah,
Okay.
you could, with all these, yeah, you can get a transaction, validate it, and broadcast the transaction to your peers.
Okay.
What you can't do is serve up historical transactions from blocks.
Yeah. Yeah, because you got rid of them.
Yeah, because you've already established your UTXO state as being valid. So what are some limitations of just having a UTXO set?
Well, you just mentioned history, right? You can't serve history.
Yeah. That is one of them. And anything else? Besides,
No counts?
huh?
I mean, I feel like the count system can't be done with a UTXO set, so it's a limitation. Like, you don't have like my Bitcoin account, you just have the UTXO associated with the key you're holding. So it's kind of like
Yeah, the account abstraction, I would say, is more of the wallet, kind of,
fair enough.
anyway.
Yeah.
I didn't hear what Bro said, but I guess history.
Yeah, that's what.
You did hear it.
Yeah.
Have a history that you couldn't, like, I mean, I don't know how the initial block download works, but like you couldn't serve those things to someone else.
Yeah, I would say.
It also, like, your node couldn't, like, so even though your node had done it already, your node could not be used by anyone else to audit the blockchain.
Yeah, that is a good answer, because I have similar things. So you have inability to view the details of and validate individual transactions from history, which is of questionable importance for a functioning monetary system, but good for auditing of algorithms, see if something went right or wrong. For example, confidential transactions, if you messed up your algorithm and the cryptography was bad, the only way to notice this is if you were auditing the history of state transitions. And we're also unable to prove to others that our UTXO set is backed by the proof of work from block headers. So we don't have proof of the state transitions or the relationship to confirm block headers. Generating proofs for this has been a stated objective of ZeroSync, while Utxos derives its proofs from bridge nodes. Bridge nodes are a delegation of storage to, again, a bigger provider of services on the Bitcoin network. See if I have anything else to say here. Nope. I'm also gonna get my charger because I did not know. I was like 30% and it went down to 9%.
Oh, you have an iPhone charger, bro?
OBS.
No, a laptop charger.
OBS can be draining.
Yeah, now you're full on camera. So,
Hey.
yeah. Exotic dancer. That could be your username.
Exotic
Exotic dancer entertain that. Just
on the
kidding.
nose.
Is-
Like, what happened to creativity?
Okay, there's an outlet right here.
I need a charger.
I got this.
None of you guys have an iPhone charger?
Oh, I
Don't
do
we
not
go
have
through
one
this
on
every
me.
month?
I do not have one on me, no.
Tossing around,
Yeah, one in my car. Actually, I do have one in my car. Let me go get it.
All right. So, let's dive into the conventional way that Bitcoin Core handles these limitations, which is having the whole history. Let's having the whole history, the normal way. And what is a chain state? So this is the lead-in of how Bitcoin, Core, manages the UTXO set. And now we actually get to answer the question of what a chain state is. There's a description that was made as a comment in Bitcoin Core that I'll show you. Faucet Banana, do you want to read? Oh, and hi Diana, I saw the comment, I just saw it now.
Chainstate stores and provides an API to update our local knowledge of the current best chain. Eventually, the API here is targeted at being exposed externally as a consumable library. So any functions added must only call other class member functions, pure functions in other parts of the consensus library, callbacks via the validation interface, or read write to disk functions. Eventually this will also be via callbacks. Anything that is contingent on the current tip of the chain is stored here, whereas block information and metadata independent of the current tip is kept in block manager.
So did you get anything from that?
A little bit?
Yeah, defining the best chain,
Um,
right? So
not.
chain state is used to determine which chain is the one to continue with, and like.
No, I'd say that's closer to like the chain manager, if anything,
Okay.
not the chain state.
Well, the local knowledge to the current best chain.
But it's fine because I have it in my own words. So, in other words, a chain state has references to the mempool in block storage via the block manager, which is this other class. You make an object.
Keeps mempool info?
Yeah, it has access to it. It doesn't keep it. It has a reference. It's just.
Say it for the camera because nobody heard what he said. Chain state actually, yeah.
Yeah, well, it says it up there.
Yeah.
That's,
Oh, I
yeah.
agree.
Yeah. It's part of the it's part of the words. It's responsible for keeping track of the UTXO set and its M coins view property. If you're reading the code, it holds received block tips that have as much work as our current tip or more and need to be validated, and it saves the in-memory UTXO set and in-memory blocks the file. Yeah, I'd say. So that's the high-level responsibilities of a chain state. Now, in Bitcoin Core, there are there can be up to 2 chain states. So that doesn't have to be 2. I'll only focus on one of them for now. The 2 chain states are called MIBD chain state, and the other one is MSnapshot chain state. And chain states are managed by a class called Chain State Manager, which is used for initializing, validating, and querying chain states. Yeah, everyone still following? Okay.
It's kind of rough,
Yeah.
There's a lot going on, it seems.
Well, there's gonna be some code on slides, which may be better or worse. Yeah, it's going.
I was watching on Twitch.
Great. Nice.
So what's a chain state?
Yeah.
That was where it started cutting out.
Okay.
That's where we're at.
Yeah, I think this second one is what we're going to focus on anyway. It's responsible for keeping track of the UTXO set. And it saves the in-memory UTXO set and in-memory blocks to file.
So is chain state is it a file? Is it?
It's what we call an
It's a
object
process?
in programming.
It's an object.
Yeah.
Downstairs.
So it's a structure that holds data and methods, or like
where's the
subroutines, whatever
object
word helps
stored?
trigger your memory.
Where's the object stored?
In memory.
In memory.
Yeah. So in memory, when we talk about it with respect to a program, it's like RAM.
Yeah. So so if you're running a node,
Mm-hmm.
then in the memory of the device that is the node
Yeah.
will be the chain state.
Yeah.
And the chain
You have an
state is this
object that is the
object
chain
that has
state.
all these qualities, details,
Yeah.
references.
Exactly.
All
Well,
right.
yeah, memory is very complex in a program, but you have this thing called like a call stack, and on it you have all the functions that you're calling as part of your program.
Uh-huh.
C++ programs all start from a main function. So you have your main function, and it branches off into different functions. Like one function calls one function, the other one calls another one, and then you could also have threads. So sometimes you fire it off like almost different pathways of things that are happening. So you could have things like initial block download happening at the same time as you calling an RPC to load up a snapshot, which I'll go into later.
Sorry, question.
Yeah.
Is Chainstate like the front of the blockchain, or is it? Because I heard you talking about like.
It contains the tip information about like, yeah, the tip, and the tip is the block that has
was
been
just
most
mined.
recently mined.
Uh-huh.
And it also has information about the UTXO set.
Okay, and the UTXO set is.
Just all of the unspent Bitcoin, like
Yeah.
all the Bitcoin that's like, that's usable.
In
Yeah.
the entire in all of Bitcoin.
Yeah.
Yeah.
But like,
The whole UTXO set.
yeah, but
Yeah,
as
that is a
oppo-
UTXO
as
set.
opposed to all of the spent,
Okay.
outputs that were like, so all the
Which would be the
previous
history.
Yeah.
So the UTXOs are what could be spent.
Yeah, we're
That's
still
everything.
spendable.
Uh-huh.
And then the blockchain is going to be the history of the spent, all of the everything that got into the blocks.
Right.
going
Okay.
Back to the beginning Genesis block.
Yeah,
Okay.
and to clear something up, the UTXO set is typically not all in memory at the same time. The Chainstate has a reference to the database file, which is in this Chainstate directory. If you run a Bitcoin full node in your data directory, you can see it. And it has a cache, and the cache holds things from the UTXO set.
Mm-hmm.
And you could configure this when you run a Bitcoin node in your bitcoin.conf file. And the bigger you make this cache, the more information about UTXOs it can hold in memory. Why would you want to hold things in memory? Because it's faster to validate that way. So
Is the UTXO set huge?
it's sizable.
Growing every day.
Yeah, exactly. Growing every day. I don't know the exact size. Like right now, I'd have to go and check. On that other laptop, actually generated a file that contains the UTXO set. So if I looked at the size of it, but I did not for whatever reason.
Got it. Okay.
But yeah, the bigger you make that cache, by the way, the faster you can sync your node. Because if you have the UTXOs in memory, as you're downloading blocks, you can validate all the transactions pretty quickly because you can check them against the UTXO set that's in memory. So how is the IBD chain state initialized in Bitcoin Core?
So what was it? The two chain states? I know there was two.
IBD?
IBD and then
Snapshot.
Snapshot.
Yeah.
which is snapshot is like the tip kind of thing.
It's something else.
Okay, you haven't got there.
Yeah, I'm not gonna get into it yet. I mean, if you want to take a guess, I could give a yes or no. But did you want to?
No, just keep going.
Okay. Yeah, I'm Snapshot
We're gonna
chain
talk about
state.
that next week, right?
No, I talk about it in here.
It's coming.
Yeah. So how's the IBD chain state initialized in Bitcoin Core? And I have a flow chart, and I made this flow chart because I didn't want you to get too lost. I show some screenshots of the code, and I have the code here just in case any of you wanted to scroll through it with me or had questions about a specific part. But Bitcoin Core actually starts from a main function, which is what I was referring to before. All C++ programs start from a main function. It's typically not written like this, but funny enough, if you look for it in the Bitcoin code base, you can see, where is it? Bitcoin D, there it is. This main function. This is something called like a macro. In the macro, this is what you typically see in a C++ program. It has some macros, for different systems, 132, blah, blah. Okay, back to
So
here.
the Win32 is a macro to do what?
For operating systems,
Oh, just for the Windows.
yeah,
It'll declare the main function differently.
Yeah,
based
as
on
a-
the operating system.
exactly. If defined, blah, blah, else, blah, blah.
Yeah,
Not
you
super
got one for
important.
Linux, you got one for message,
Oh.
no signal.
Yeah, see, you have all these references. Apple poll is broke. But starts at main function. If you're ever wondering where to look when you're starting your Bitcoin node, it will always start here at the main function because Bitcoin D starts here. Main function. Then you go to something called app init.
Initialize?
Yeah, pretty much. And then app init main, which is sometimes you don't naming things is hard. Yeah, that's just all it is. App init main. Then you go into something called load chain state. You go into a whole bunch of other things in each of these, but I'm trying to make as linear a view as I can to explain the chain state concept. So app init main goes to load chain state. In your load chain state, first you go to initialize chain state, and then you eventually go to complete chain state initialization. And then these init your coins DB, which reads the UTXO set database from file, and then you also initialize your coins cache, which is the in-memory UTXO set. Yeah, this diagram kind of makes sense. We can go back to it as I go through the next slides too. So now let's look at the code. And I put in slides, again, these snippets. See, I have these messages. I deleted the stuff in the middle so I could take a small screenshot and confuse you guys less. But you have a main function and blah, blah, and you see, just like I had in the diagram, it calls app init. And it calls it with this thing called a node context. Not important for the thing I want to look at. Then this is an app init on 154, and this is still in that function, 217, blah, blah. Then we go to app init main. Okay, still somewhat unimportant because we're not close to the chain state information. App init main, in this function, you can see that we load the chain state. We actually invoke something called cache exceptions, and we give it a lambda that loads the chain state. But again, all details. Then you can see you get a status after you load the chain state, and it might be success, and this is what you want, of course. And if you don't get a success, then you have to return an error. And you have all these log warnings and all this blah, blah. So load chain state makes a call to initialize chain state. This is, back in this diagram. We're in load chain state right here. You make a call to initialize, and we'll make a call to complete. So let's go back here. We make a call to initialize chain state from load chain state. Again, I deleted stuff. And this is initialized chain state. So remember I said that we make an IBD chain state? Well, the code is somewhat descriptive here. And you can see MIBD chain state is equal to this thing. These are details, but you can see it's making unique a chain state, right? Like, it's close to English in a way. It's making a chain state. And you give it this mempool reference, and you give it the block manager reference, which is shared amongst all these chain states. And then you give it a reference to itself, which is this chain state manager, which might get confusing, but again, detail. And then you set something called the active chain state on your chain state manager. And you return the chain state when you initialize it. But it's not like we use the return value here. So then we go back to load chain state. So we move back in the call stack to a load chain state method. And then we do that other part of the flow chart where we go to complete chain state initialization. We give it the chain manager, the cache sizes. Again, you could set the cache sizes or your in-memory UTXO set dependent on the values that you configure in your bitcoin.conf file. Okay, everything's still fine. Are we still following okay? Yeah? Oh.
More or less.
Okay.
Some of this is making sense, some of it.
Okay. I tried to make it, again, it's like there's a lot of other things that happen in these functions. So I just try and highlight the things that I want you to look at. So this is in complete chain state initialization, and it's where the coins views gets instantiated into M coins views, which is a property of the chain state. And coins views is a class that manages the DB operations for the UTXO set, as well as the UTXO set cache. So coins views is a class or an object, remember this entity in programming that has data and methods that operate on this data, and it's all in coins views to manage the UTXO set. And where's my mouse? Okay, there it is. Init coins DB is initializing this, and init coins cache initializes this cache in the M cache view. So we have something called cCoinsView too. So this is the class that the UTXO-DB class, cCoinsViewDB, and the cache class, cCoinsViewCache inherit from. It's cCoinsView. So you have this object or this entity in programming called the CoinsViews, and I hate that it's coins views. It just sounds weird, right? You think it's like, yeah, coin views or like something else, but you know, this is just whoever initially programmed it, they wanted coins views. So yeah, it's views with an S. I missed it here, but I just hate the grammar. Yeah, but I think this is cCoinsView and not cCoinsViews, but let me double check. cCoinsView, as we use cCoinsViews. It's view, but this comment's actually wrong, so you know, 10 years ago. Oh, maybe it was cCoinsViews for this one as well, and they renamed it. No, it's not, because Peter Woolley made a commit 11 years ago, and it was Michael Ford, yeah, 10 years ago, who put the S. But there's the coins views, and I think that's why you got confused. Coins views. And again, they're very annoying naming.
What's a coins view again?
So the coins views is an object or an entity that just controls.
Inherited for.
Oh, the cCoins view
Yeah,
is different from the coins view.
Yeah, what are either?
Yeah, the coins view is an object.
Without the C.
Yeah, the coins view is an object that Bitcoin Core uses
Okay.
to write UTXOs to disk
Okay.
and to manage things, UTXOs in memory, so on RAM
Okay.
or in RAM.
And C-coin views are
C-
inherited. That's a property.
It's not inherited in coins views, which makes it a little bit confusing.
This is
Yeah.
Okay.
So I think I had a diagram for this as well. Here we go. So you have, again, the coins, actually, let me look at this diagram first. So is it this? All right, you have something called the cCoinsView. And cCoinsViewDB inherits properties from the cCoinsView. Then you have this thing called cCoinsViewBacked. And then you have cCoinsViewCache and cCoinsViewErrorCatcher, both inherit from cCoinsViewBacked. Again, a little confusing, but when these classes inherit from cCoinsViewBacked, it's indicating that it can wrap a cCoinsViewDB or anything else that inherits from cCoinsView. Yeah, I know. I don't like this either. You know, it's confusing for me as well. Yeah, this is just what it is.
Yeah.
And I hate that the cCoinsView cache is different from the coins views. But again, this is just what it is.
Unless we make a PR.
Yeah, and
But
I feel like
11-year-old
refactors
piece of- yeah, it's-
are frowned upon that are just wide refactors, especially if you wanted to make this hierarchy a little bit different.
Fair.
But cCoinsViewBacked, basically if there's something that inherits from it, it means that it could accept another cCoinsViewBacked or cCoinsViewDB. So it wraps things. Yeah?
But what is the purpose of cCoinsView?
Right. That's-
Yeah, so yeah, cCoinsView is, so CoinsViews
Was an object.
is an object, and there's properties on this object
Yeah.
that inherit from cCoinsViews.
Okay.
Yeah, so you have the thing or the object that allows you to access the database or the file in Chainstate, the Chainstate directory, is cCoinsViewDB. So you make a cCoinsViewDB first, and then you actually give it to, I think it's cCoinsViewErrorCatcher for, next, and then you give the cCoinsViewErrorCatcher in cCoinsViewCache. So you wrap the database accessor in these things because they add extra properties to just the database view. It basically allows you to have an in-memory view of the database. These are responsible, or this is responsible for maintaining the in-memory UTXO set, while cCoinsViewDB is responsible for managing the on-disk UTXO set. So if the cache doesn't have anything, it'll refer to the cCoinsViewDB. Hey, go to disk and get something. Yeah, do I have anything here that helps explain? Yeah, cCoinsViewDB and the cache class cCoinsViewCache inherit from blah, blah. That's what the diagram was supposed to say. C coins view is not inherited by coins views. Coins views has the M coins views and the M cache view properties. So C coins view DB is in wait. I think maybe I got these property names wrong. But
I'm not surprised.
yeah, there should be a DB property on coins views, and then there should be C coins view cache typed object in M cache view. I have some code. That's why I have the code for. So we could always, and you'll see it. But I'm trying to give you some more tidbits of understanding before we jump more into the code.
What is the C in C coin view?
I don't know.
That's just what it is.
Yeah, exactly. Maybe it's cache. There's like a naming convention
cache.
that they have. I don't know. That was a guess.
Cache.
I don't know that for sure. It's a guess. There's a
Well,
naming
kinda,
convention.
Yeah, that's a good theory.
Yeah, there's a naming convention in specifically the Bitcoin core code base.
And this is following it.
And yeah, and a niche of the C++ community program things like this.
Oh, maybe that's the C.
Not all C++ programs are like this, but there was a convention, and Satoshi did program this way, where he'd prefix with letters sometimes,
I see.
and they mean different things.
Uh-huh.
So the chain state has the coins views objects. Remember, the coins views is responsible for the on disk and in memory stuff, and to retrieve the cache, and again, the cache has access to the database, or the coins view that can access the database, the cache has access to it, and you get the cache by calling coins tip on this chain state.
Uh-huh.
So we're changing. Usually, it would go chain state. You get your coins views from the chain state, and then you get the cache view. And the cache view internally has a reference to the coins view that controls the database stuff. So to easily get the cache view, you could just call chain state coins tip. So it saves you a level of property accessing. So initialization of the chain state directory. I just wanted to note that this is in the chain state directory in your data directory. If you run a Bitcoin node and you know where to find that, you can typically go in that folder. So where and when do outputs get added to the UTXO set? So the UTXOs get added in add coins, which is the primary place to call ccoins view cache add coin. Also, wait. Sorry, I wanted to see if I had any questions I wanted to ask people. I did have questions here, but I don't think you guys will like them. What do you think is the purpose of having a base class like ccoinsview in the context of UTXO management? Probably not. Second.
So it's got to be so you can keep track of these attributes which are passing. Otherwise, if there's an object with them, how can you fill the wider, I don't know.
Or yeah, well, the ccoins view is different from this coins view, but
Oh, God.
but the coins views with plural. Again, I shouldn't have.
coins view.
But this is this is my mistake. It should be an S like here, but yeah, the ccoins view is something that the attributes of your coins views inherits from. Again, I think that question was not. How might the inheritance structure of these classes impact the performance and scalability of Bitcoin? I could ask the question and you could watch it again and answer at home. I don't think it's conducive to ask and figure it out here.
Well, what's the answer?
What? Why do it this way?
Yeah.
Or why? Ccoins view, I think, is way too similar to coins view.
Right.
For coins views or coins views to not inherit from it. So I don't like this name convention, but I understand what it's for. The ccoins view.
What is it for?
The ccoins view helps demarcate a class that inherits it as a property on coins views instead of anything else.
And why is it beneficial for it to inherit it as a property?
What it inherits, it derives its class from it.
Okay.
Why is it useful for the coins view
Yeah.
to have a ccoins view property?
Right.
Because there's separation of logic. So the coins views has a ccoins view cache, And the Ccoins view cache manages things in RAM. Now the Ccoins view cache contains a reference to the Ccoins view DB. In the Ccoins view DB, you can put all the logic in there for maintaining the file on disk. So it's separation of concerns.
Is Ccoins UDB also in memory?
The object is, so for performing
Yeah.
but
But it's used to then actually put data onto the disk.
correct, yeah. Okay, I think,
Little things are.
yeah.
great things.
Yeah, I thought I had more like code of like this specifically, but I guess I took it all out. Because it can get confusing. And I also have this code right here if you really wanted to see it, right? So you have this Ccoins view. This is the coins views, by the way. If we actually wanted to see it. Yeah, I want to move past the coins views, but just so you guys have a better visualization of how the actual code looks. You have this coins views. Again, this manages the UTXO set. You have the MDV view, which you don't need to access through here. You could access it through the cache view because there's a level of indirection. And yeah, this is the coins views. Again, this is very annoying with the S's in both. I don't know if this helps understanding or not. You know, you can take a look.
That's, so James Irvin, it says.
Yeah, he's made a lot of changes to this.
Because that's assumed UTXO.
Yeah, while he's making assume UTXO, he's refactored a lot. And he's added a lot of fixes to like the UTXO state management. And I'd also say within the past couple of years, like block storage in general, you know, and random things. But he has made a lot of good changes. But this obviously is still very confusing. Having like coins views and then Ccoins view DB and then the Ccoins view and all that other stuff.
This has been going on for 15 minutes.
Yeah, I just wanted to establish a good understanding before I go to future code. So yeah, where and when do outputs get added to the UTXO set? UTXOs get added in this thing called add coins. Add coins is called from update coins. It's called from CTX mempool check method, and it gets called from C Chainstate roll forward block. And update coins, the first one here, is exclusively called from connect block. Why might that be?
So that
Yeah, so you only update coins when you connect the block, right? You can only really register UTXO in the UTXO set once it's been confirmed. There's ways to handle reorgs. I don't go into it, but there's like these things called undo files.
I'm sorry, I must have missed the connect block piece.
I don't think
See,
you mentioned it before.
yeah, I didn't mention it before. I was just saying like just from the words. Connect block is just in a place in the code in Bitcoin Core where when a block is accepted and they're connecting it to the rest of the blockchain.
So that's like
Yeah.
the chainy part of blockchain.
The chaining.
Yeah, exactly.
does the like coin sketch use connect block at all?
You call update coins from connect block, and update coins calls add coins. Add coins calls add coin. Yeah, and then that is part of the Ccoins view cache.
Okay,
Yeah. So it doesn't call it directly, but if you
Yeah.
drill down a little bit,
yeah.
then yeah, it ends up updating this Ccoins view cache, which eventually updates the database when it's time to flush the cache onto disk, is what they call it, or like save the cache onto disk. So, yeah, and it is called from CTX mempool check, but we don't actually want to add a UTXO to our UTXO set just because it's in a mempool. So what we do instead is we just use our like a Ccoins view cache, we copy it, and we try and add everything from the mempool into this UTXO set just as a validation procedure. So, and again, that's like a copy. So if you look at, I think it's mempool duplicate. Yeah, right here. We have the check, and then you just kind of make like a duplicate. Where is it? It's right here. And then you try and add some things. Again, like more of an optimization. in roll forward block, only does stuff when a Bitcoin D or like a Bitcoin node did not finish flushing / saving the in-memory UTXO set, which is the cache, to disk, and it needs to add the outputs from the blocks it wasn't able to. So if it was in the middle of committing things from memory to storage, and something happened in the middle, and it wasn't able to finish adding all the UTXOs from the cache, from these blocks, onto disk, then you actually have a reference. Because before you actually perform this operation, you say what block you're trying to save all the UTXOs from to disk, and you say what block you're on. And if something happens in the middle, you can go back and say, okay, I have to redo this whole thing to make sure I didn't miss a UTXO that was in the cache that wasn't committed to disk.
And that's roll forward block.
Roll forward block, yeah. It needs to do it here because the cache is cleared on shutdowns. We don't know what we're missing. Yeah, we don't know what we're missing. Again, if an error happened, so we have to use roll forward block to look through these blocks and add them all manually.
And that happens after validation.
Yeah.
Confirmation.
The UTXO set at this point has been validated, the thing that they're saving to disk.
One confirmation, and now roll forward block can be.
No, roll forward block is only like, you typically don't want this to do much. It only does something if you did not have a graceful exit of your Bitcoin node.
So
And-
it just got rugged, unplugged.
Right, exactly. It died. You know, so you'd want to use roll forward block there.
So I think maybe it was like the ordering of the sentence, especially the last sentence. So you're saying like if Bitcoin D were to shut down unexpectedly,
Yeah.
it would not have properly cleared the cache, or the cache is automatically cleared.
The cache is automatically cleared on
And
shutdown.
So, and so that's why, but like even if it's shut down incorrectly.
Uh,
Cache disappears.
yeah.
Okay.
Yeah, it
It's
always
not, like,
disappears.
yeah, it's not
Whether it's a
flushed
good.
properly,
Mm.
but it just because it's in memory. If your program dies, the
I
memory
got you.
goes.
So,
Yeah.
so then when it starts up again,
Mhm.
it's like, oh, you know, I had this problem, so let me do this thing.
Yeah, let me look at the
forward
blocks
block.
because I don't have anything. I don't have any.
You don't have anything in cache.
Yeah,
You want water?
I think I'm okay. Hello. All right.
Voice works again.
Yeah. So yeah, if ungraceful shutdown, you come back up, your cache isn't there. Even if you have a graceful shutdown, the cache is always gone. But roll forward block happens when you were trying to flush the cache and you weren't able to. So now you have to look at the blocks. So let's look at add coins. I'm gonna check the chat just in case. Nope, no one's commented. Perfect. Add coins, and I try to include like where these methods and functions are. So this is a function on coins in coins.cpp, and like the source. So if you wanted to follow along and go in the Bitcoin core directory, you know, even after if you're watching the video, which I'll try and upload to YouTube. So add coins. Add coins is it's compact. So it's given a cache as an argument. You check if this transaction is a Coinbase transaction, the thing that pays out these miners. You get the hash of the transaction, and then you look through all of its outputs, or the V out, and you see if the cache already has the coin, and if it is, you just explicitly mark it as something that, or no, you pass into this function whether you're okay overriding things or not, you know. And if you're okay with overriding things, then you at least want to know. So it checks if it's already in the cache. If you're not okay with overriding things, then it just goes to whether it's like the Coinbase or not. And I guess the Coinbase, if it is, then it would be okay to overwrite.
So,
I guess for reorgs and
so,
the like.
this is if you have a smaller cache, then it'll be using this to overwrite.
Yeah, or it depends where it's called from in the code, or whether it's like okay to overwrite or not. Yeah. And then you use the cache that was passed in as an argument. Again, the CCoinsView cache, which is the highest level, not the highest level. It's, yeah, the CCoinsView cache, it came from a Chainstate, and it came from a CoinsViews.
So CoinsViews tells the chain state, which is going to tell CCoinsViews cache, and it's going to have
Yeah, well, or you extract.
coins.
Yeah, you extract the cash from the Chainstate coins views, and yeah, you extract the cash from the coins views. Then you pass it into this function, and then you say add the coin, and you add the out point, and you make this thing called a coin, which is another object that you're gonna be in memory, and you give it certain information. So you give it all the information of the output that you have, this whole v out in this index. This is a for loop, so it's gonna add all of the outputs of a transaction to this C coins view cache. And yeah, I love some of these. Like I have git lens, and I think this is kind of cool just to see, like this line in particular was changed 7 years ago. So a lot of this code is still pretty old, even with all the refactorings that had to be done for Assume UTXO. Okay, this is add coin. So we assert that the coin isn't spent, it shouldn't be. And we do this other stuff. Is unspendable, return. So this is kind of interesting, right? People always ask, or actually it might be more, should we look at is unspendable of what goes in the UTXO set?
It's undependable.
Oh my goodness.
Is that a Freudian slip?
Yeah, I don't know where my mind got that, but let's get it. It's unspendable. So people always wonder what happens to outputs that have an op return. Does it get stuck in the UTXO set? And the answer is no. No, it does not, because it does this check first. And if it was unspendable, then you just return. You don't add it to the UTXO set. That's fine. So also, if it's you have a size of a script that's too big, then it's also not. So yeah, there are some rules. It's the UTXO set.
Would the size of the script in that particular check be considered a standardness rule or consensus?
I would say it has its consensus at this point. Yeah. The UTXO sets have to be consistent between different implementations.
Okay.
And also note that this is like 10,000 max script size. So
It's pretty big.
yeah, but Taproot doesn't, for the execution script, Taproot doesn't have a limit, right? So how can this be?
Yeah.
Does anyone have a guess?
Well, is that from the commitment to the Merkle?
Right, yeah. This is only checking the script pub key. And since SegWit, you either put a hash or you put a public key for Taproot, right, as a script pub key. So this size check is always going to pass for those. Now you put the actual execution script in the witness. So when you spend it, it's not going to be stored in the UTXO set, which is some arguments that I hear from wizards. Like this isn't calling up the UTXO set, at least. It's in the witness, and the witness doesn't get stored. And they're correct, it doesn't get stored.
Correct, so it's better. Objectively a better.
Yeah, but it's still you're still getting, I think, things in the UTI, like as far as like there are these transactions that are not spent. So you're still putting something in there. It's just not right. It's just not as big.
Yeah, well, you're putting in SegWit v0 you're putting a hash, and in SegWit v1/taproot it's like a public key pretty much. So it's still a pretty minimal footprint. Then you could make the case that they're making outputs, but it's something we don't really criticize as much. I'm not saying that what they're doing is great. I'm just saying that this was an argument that was made by them when they were doing their inscription stuff. They said this does not bloat the UTXO set with the sizes of our JPEGs, and that is correct. Because if it was unspendable, it would return. And yeah. So then you have this iterator. I don't want to go into all of the details, but you do this thing called emplacing, which adds something to the cache coins. If it wasn't inserted, then you remove it from like the space, because you're tracking. This is like you track how much space the UTXO set is taking in memory in this thing called dynamic memory usage. So you add it down here. So if it wasn't inserted correctly, then you subtract it, because this addition always happens. You have some logic about possible overwrites, and there are some conditions where you'll throw an error like attempted to overwrite an unspent coin. And yeah, I've explained the concept of dirty before. Back when I was doing, well, I don't know if you went to that one or not.
What is dirty?
Yeah, but it was in the block storage one, which is like, I don't know, understanding Bitcoin's worth like 4 or something. If something is dirty, it is
You're
has.
doing a false sport, referencing all
Uh-huh.
serious work rather than.
That is not what dirty is. No, dirty just means it hasn't been committed to disk.
Okay.
Yeah, it's dirty.
Hasn't been committed, it's dirty. Has been committed, it's fresh.
Yeah. Well, actually don't know the term. I didn't look at the fresh terminology here, but dirty in general, because they use it in other places in the Bitcoin code base. Yeah, it just means that it hasn't been committed
So it's
to
in
disk.
memory
Yeah,
and it hasn't been committed to disk.
yeah,
And
and it needs to be, or it eventually will be committed to disk.
what do you mean? Oh, committed, just written.
Yeah, right into the file in Chainstate. Okay, so then we go to assume UTXO. I thought I had the code to flush. If not, like I said, I still have the code right next to here, so we can look at it after if I don't. But flushing is when you actually save the UTXO set to disk. Not the UTXO set, the cache that you have on your Bitcoin Core node, that's when you actually commit it to disk. And I wanted to show the flush, but maybe I guess I just didn't include it in this code examples. So let's just go to assume UTXO. Anyone know what assume UTXO is or how it works? Yeah?
So, as I understand it, there is a hash that's committed to as a collection of the blocks up to a specific point in the chain that can be put into the initial block download to start from that point instead of the genesis.
Yeah, that's absolutely correct. Well, yeah, it's a project so that you can have a hash in your Bitcoin or known by your Bitcoin Core node, and then you could load up a UTXO set that contains the UTXO state at that point in the blockchain. And that way you could start validating blocks immediately from that point onwards. But you would think, hey, this requires a lot of trust, so there are some nuances to this approach and things that they've added in to try and minimize the trust. If I'm giving you my UTXO set, how can you be sure that it's okay? And what safeguards does Bitcoin Core add in to make sure that a user doesn't get a bad assume UTXO set? So assume UTXO is a project that allows a Bitcoin node to bootstrap a UTXO set. It works by one individual taking a snapshot of the UTXO set and distributing the file to some consumers. So if I were to call an RPC command, I think I have it down there, but it's like dump TXO set or something like that. I get the file and I give it to all you guys. You load an assume UTXO snapshot, or loading an assume UTXO snapshot does not stop a Bitcoin node from downloading and validating the entire blockchain. So even though you load up a UTXO set at a certain block height, it doesn't mean that you're not going to download all the blocks from the beginning. There is a background sync that happens.
The background sync continues, but this allows you to validate quickly.
Exactly. You can start relaying and validating transactions at the tip of your assume UTXO set
while the
hash.
background sync continues.
Exactly.
Now, is that always true of assume UTXO? Like,
Yeah,
yes,
always
you will
true.
do a background download.
Yeah.
Like, you couldn't just take that snapshot and then just go from there.
No,
Okay.
it's just not how it works.
You can use it in that way, but it's not how core.
Exactly. Bitcoin Core will always download the entire blockchain up to that checkpoint.
But even if there were the case that you were not able to keep up with current blocks, you could still use the validation of Bitcoin Core. So,
At its tip.
yeah, it's different.
But so another caveat here is a background sync is performed and all amounts received by your node's attached wallet will be considered unconfirmed. So you still don't want to spend, and they've built in a lot of safeguards in Bitcoin Core to not allow you to use assume UTXO in a way that they consider unsafe. Although I think there should be more choice given to the user, of course. Like if I don't want to do the initial block download, do I have the choice to? And the answer right now is no. You have to do this IBD.
Yeah, and hopefully I would wanna see that on the Gossip network, you would be able to share, like hashes.
Yeah, well, that's
That's,
that'd be a lot of trust with all
Yeah,
your
exactly.
peers, and yeah, I don't think that would fly as a PR change, but it could be another forked project. you know? Also, this doesn't work today, and I'll go into that as well when I say how they're created and loaded.
So Bitcoin Core actually has done work to sort of stop Assume UTXO, but the support for Assume UTXO didn't start in Bitcoin Core, did it?
It did. It was
did.
they haven't made moves to stop it. They've
Okay.
just made moves to like make it safer.
Okay.
cause it's taken like 5 years or something like that.
Yeah.
I see.
Since, in order to fully like refactor code and then after sort of like having it in, add the safeguards or whatever.
Okay. How big is the current blockchain right now, like to download?
I don't know, gigs, you know.
500,
Ma-
600 gigs.
Yeah, many
600
gigs.
Okay.
Hundreds of gigs.
So, yeah, the
It
major.
recommends 500, but I feel like it won't work unless you
Uh,
have 575.
Yeah, I have a pruned node, so I just don't know.
I mean, I seen probably, what was that, 3 weeks ago when we were doing
Uh-huh,
that?
yeah.
And I needed about 6.
Oh, that's right. Yeah, you did.
The, but one of the major bottlenecks is like bandwidth that you have to talk to the rest of the network to get the blocks.
Uh-huh.
So this could also help there, where you maybe can do other things with bandwidth. I'm not very familiar with necessarily the infrastructure, but things that like when you have extra bandwidth, you're able to sync in your own time. You don't have to necessarily do the full sync and then you can start using it.
Mhm.
Yeah, and you could have a view of
Yeah.
the UTXO set that's most likely correct depending on like your confidence in the person who gave you
Yeah.
that snapshot. Until it's fully validated by this initial block download background sync. And so yeah, they wanted this in Bitcoin Core. Like they don't work against it; they just try to make it as safe as possible. So this is all part of the design.
But it's just not functioning yet.
It's not
does
function.
I think.
Yeah, you have to build it yourself.
Yeah.
Yeah, so it's like it doesn't work out of the box. If you have to edit the code, so I say it's not really functioning. Like if I have to edit the code just to make this thing work, then like is it really a feature?
Is there
But
an edit you can make so it's out of the box for people in the future?
like if I build it for you, then
Yeah.
I could. Oh yeah. It's a very easy change to enable it for people in the future. It's just not in there right now.
Alright, but I mean, why isn't there a like change assume UTXO like already there that you could just go and it works out of the box?
It's kind of like
Yeah, that's
core thing.
why isn't there? I mean,
Yeah.
that's like I can never say why a PR is made or not.
But
The-
there's not a good reason that
No,
like,
no.
it
I
can't be
I personally
because-
don't think there's a good reason. The last slide I'll show you. I don't know if it's an issue or pull request, but Stores, he's a Bitcoin Core contributor. He is working on. I think it's a PR of getting his snapshot into the official Bitcoin Core client, so that you could at least validate his. But yeah, I can't actually give you my own without editing your Bitcoin Core, which is like very annoying. Yeah.
Does running a pruned node require you to first download the entire blockchain?
Yeah.
Okay.
Well, you don't have to have it all at once. Like you could prune as you go.
I see.
Yeah.
Do it
I see. So it's
and then
validate. So
it,
it's
and then-
validating.
yeah.
that you
Yeah,
download
exactly.
more.
So
Okay.
I have 10 gigabytes on
see.
that laptop. I have a Bitcoin Core node on, and it deletes. It's like a rolling window of blocks.
And it
that it keeps it.
And as far as the node goes, it's still a legit node according to the network.
It's
not-
fully validating. Yeah, it can't serve all historical
History-
blocks.
history.
Yeah,
It's just- okay,
but it is
I see what you're saying.
validating everything because the UTXO set is valid, and I could say what is a valid transition or what isn't, what block is valid
I see.
at the tip,
Okay.
or I could serve up to 10 gigabytes, right? How are UTXO snapshots created? So creating a snapshot. As someone who wants to be benevolent and share the UTXO state to bootstrap nodes, you need to explicitly run the RPC command dump tx outset. And below is the output from running it on my node, which is synced to June 6th, 2024 today. and it took about 6 to 7 minutes, somewhere in between there.
To create.
Yeah, to create.
And that's the output
Yeah, this is the output.
because it's all hashed.
Yeah, Randy, and this is where it's stored. And a lot of transactions. So how's the Assume UTXO chain state initialized in Bitcoin Core? So Assume UTXO is its own chain state. And initializing a snapshot chain state as a beneficiary of a UTXO snapshot file. So if I wanted to use your UTXO set file, then you'd give it to me, and I'd run loadtx outset with the path to your file on my computer. Again, the caveat to this is you need to manually build Bitcoin Core with the parameters available in the chainparams.cpp file. Again, I include all the paths, so if you actually wanted to do this, you can. Source kernel, chainparams.cpp, and blah, blah. And specifically within the M assume UTXO data in CMain params. So they have an example in testnet of how you do this. You put the height, you put the hash serialized, this is like counts all the transactions up to this point, not in the UTXO set, just in general, because it gets some other metadata about the state that we're at, and it gets the block hash. So you could do this for main, you just have to do this yourself if you wanted to use it and build Bitcoin Core yourself. So what happens when the background sync finishes? So you go to something called maybe complete snapshot validation. These funny names, right? Is the function that's called to validate the background chain state. It's called from connect tip and load chain state. Connect tip is like connect block, it's just, there's, yeah. Call stack includes a lot of different things that sound similar, but you kind of still understand when it's being used. When a new block comes in, you're connecting it. So I put here. So when a block comes in and on startup RPC respectively. Startup RPC, I did not mean to put RPC here. I guess I brain farted, but just startup. When a block comes in, this is run, and on startup, this is run. And maybe complete snapshot validation specifically determines if the IBD, initial block download chain state, is valid up to the block hash where the snapshot was loaded from. And it disables the IBD chain state from progressing if it is. Why? Because we don't need to progress past the point of our Assume UTXO snapshot because our node has validated everything up from there onwards ourselves, assuming that was valid, and it was.
Okay, so when you said disables the IBD chain state from progressing, that means that it then fills in the rest of what you already had.
Yeah,
Okay.
from the point that you loaded up the
Yeah.
Assume UTXO snapshot.
Yeah, as
onwards.
opposed to the IBD just continuing to download more blocks. Like you
Right, that you've
already
already,
downloaded all
exactly,
these blocks,
and
so-
validated it, so,
Yeah, okay, gotcha.
yeah.
So this is just the process of like comparing the hash that you have from
Mhm.
what
From the
you've-
snapshot, yeah.
Like, well, from the snapshot versus a hash of like what you IBD.
Exactly, getting in the background
And they
sync.
should be the same.
Yeah, they should be the same. And if they're not, it actually, I didn't include it in, but you exit out the program.
Really?
Yeah, there's like an error. I mean, what do you think should be done?
Like, well, then I would assume that your snapshot was faulty, and then you just keep going with the IBD.
Oh yeah, it is. I mean, that stuff isn't. It's not like it's deleted your IBD. It just returns some error. Maybe it doesn't shut down, but it returns an error.
Yeah.
But yeah, I'd have to double check if it actually led to a shutdown. This is what I was assuming when I saw the error return. And this is how it looks. Again, a lot of code here. Snapshot, block hash, blah, blah. Yeah, I don't think there's anything that interesting here. You get the snapshot tip height, active height, the snapshot base height. So this is what you validated right between these two. You make sure all this stuff is okay. So you skip this step if one of these conditions is true. So like if you don't have any blocks or a tip in your initial block download chain state, then it's skipped. It's like, oh, he clearly hasn't downloaded anything yet. If you don't have a snapshot, so if it's not usable, it's typically if you don't have a snapshot at all, it skips this, but the code still comes in here. Anything else interesting? Handle invalid snapshots for the next
Well,
one.
what about, like, it seemed like that last part, handle invalid snap, isn't that what I was asking you about?
Failed to validate the Assume UTXO snapshot state. This indicates a hardware problem or a bug in the software, bad software modification, invalid snapshot to be loaded. This is just the error message. We haven't used this yet. Yeah. This is what we call like a lambda. It's like something you pass into something else. So like this is the rest of it. So yeah, you have these, you define that string up here, a bilingual string as user error.
Bilingual. Doesn't look
No, it does not. And you put that into a bilingual string, you do this logs, you get the IBD chain state, you get the snapshot, you make sure it's disabled, true, blah, blah, do these other things. I'm trying to find where you, so this is where you use the user error, invalidate coins DB on disk, get notifications, fatal error. So yeah, this is in the case that things did not go well. This is a lambda. It's not called yet. You defined it, called handle invalid snapshot. So when you do find one, this is how you handle it. And you say the snapshot is disabled. And you have this error. And then you give a fatal error, again, which I assume will terminate. But it might not. I haven't checked. This get notifications fatal error paradigm is like, you kind of send off something asynchronously. So the control flow for like finding what happens in this case is a little bit annoying for me. That's why I didn't actually track, or all the listeners to this event do. So yeah, this is what we're actually checking. Index new get block hash. If it doesn't equal the snapshot block hash, then we print this log and then we call handle invalid snapshot. So this is where we actually check this block hash.
Is there any way to get all the like active listeners?
For like this get notifications part. Like during execution, I don't know if there's like a method to get the listeners. I think you can like command Shift F or like do a global search for certain things, signals that. But yeah, you have this thing, blah blah handle. All right, I think enough of here. Maybe complete validation, some other stuff. Anything interesting here? Missing chain params. Sometimes you give more detailed error messages. Yeah, this compute UTXO stats is kind of interesting. This is kind of what you use to create snapshots. So there's a part where you create a snapshot of your initial block download chain and compare it to your snapshot that you loaded in from the RPC calls. Anything else? So yeah, this is where we do that, right? IBD stats hash serialize. If it doesn't equal the assume UTXO AU data hash serialize, then we say there's a hash mismatch. We do this, we get the hash of it by using something called like the stats. And then if everything went well, we disable the IBD chain state, and that's fine. And we continue with the snapshot chain state. And eventually, on our next restart, we actually remove the snapshot. We just call it a regular chain state, right? Like we make it the primary IBD chain state. How load chain state interacts with snapshots. So again, when it's done, load chain state gets run on startup of your node. And if it, this is a detail. If you're re-indexing, you delete your snapshot. You can't re-index with your snapshot. And then this part, this is called from load chain state, and it deletes the snapshot file and creates an IBD chain state from the snapshot chain state. And maybe complete snapshot validation. Is this? I don't think it actually happens in here. I think it happens in load chain state. This is a mistake. I remember, and I don't. Sometimes I write, But yeah, I think the deletion of the snapshot file should happen in load chain state, and I could verify that pretty easy. Load chain state, let's see here, and maybe complete validation snapshot. Yeah, so on, that's what I'm looking for. Snapshot success, we get all, initialize chain state, activate chain state complete initialization. Here we go, validated snapshot cleanup. Yes, you do the cleanup in load chain state. And then you initialize a new chain state using information from disk and information about the mempool to make primary IBD chain state, because you have downloaded everything. So snapshots are meant to be replaced. They're to bootstrap you. They're temporary. Anything else? No. I have when they clean it up. So I did. Okay, load chain state. But yeah, this is where it's cleaned up. Don't remember putting the screenshot in. So yeah, the cleanup doesn't happen here. Here's where we disable the initial block download and validate that what we downloaded matches with our SumUTXO checkpoint, but it's not where we clean up our snapshot state. Here's where we clean up our snapshot state. Where's that cleanup? Right here. Okay, so how does the IBD chain state get blocks if we're validating at the tip of AssumeUTXO? So if you started your Bitcoin core node with AssumeUTXO at a certain snapshot, how are you like getting blocks both at the tip and historically? And I just want to show in the code where this happens. So in this source net processing.cpp file, we have something called send messages. This is where we send messages to our peers on the network. And this is where we're specifically supposed to be sending like get data requests for blocks. And in the middle here, you see if we have a background sync in progress and we don't have a limited peer, which means like they're not pruned or anything, they have all their history. You do an extra call to try downloading historical blocks. So if you have like a budget and you're already at the tip of your AssumeUTXO or like the recent chain, then you could start your IBD because you have extra time, 10 minutes in between every new block. So why not try download your historical ones? More code. Yeah, sorry if the code was too much for all of you, huh?
What was this one?
This is try downloading historical blocks.
Okay, this is
Yeah, just try, man.
Yeah, so this is like the details of the method and peer manager
There is
implementation.
no try. Why isn't it download historical block?
Huh? Well, we have this like find next blocks, and we do have early returns here. But like also find next blocks. There's like a window that you could have, and you also took in the budget here. Get in flight budget. Yeah, that's the second one. So yeah, you do have a budget or count of how many you can get. So you try and get as many as you can. But you can't have too many in-flight blocks that are coming from you from the tip of the chain.
Is this where, I guess, like certain networking calls would be made, or is that?
Yeah, this is a kickoff for all send, or here's better, in send messages in net processing.cpp is the kickoff for all the messages that we send to other peers.
And then is that using what, gRPC or?
No, just
Or I forget what.
you could use like raw TCP.
Raw TCP,
Yeah,
that's what-
you could also use like I think we have Onion peers, and right now there's the peer-to-peer encryption. I think it's like BIP 324.
Yeah. Yeah, I was not familiar.
Yeah. Although there's like JSON RPC if you wanted to
Okay.
call like Bitcoin D as a client. Yeah, and then add a practicum, which is like the best way to see if you understand well what I had in the presentation, which is try and look at some pull requests with AssumeUTXO and see if like they make sense. So I was gonna pull. I haven't looked at these like before. I just got this page. So I was like, oh, like maybe it'd be cool to like try and pull one up and see if you guys could understand what the issue is saying.
Let's do it.
Non-immediate
Yeah.
periodic tasks, variable runtime.
Yeah, here I'll pull it up on I don't have a browser on this one.
Oh, the Bitcoin
Yeah, this is
Core.
one's a
Okay.
screenshot. I need to move this over here.
There we go.
This is from last session.
I wonder why they have AssumeUTXO on the Bitcoin kernel. I guess they're adding.
Oh, why it's in the file? Yeah. Some things they want to make a library, and I'm not quite sure of all the plans they have.
Yeah.
Yeah, this obviously write tests. Pause IBD during AssumeUTXO snapshot load. So Shorts, he's been doing a lot of work towards this. The load TX outset RPC call should cause IBD to pause until the snapshot is loaded and the snapshot chain is activated. So you do this IBD, like always. You have to explicitly activate a snapshot if you're ready to get a UTXO set that someone distributed online. And when you do, he's saying that it should cause IBD to pause and for you to focus on getting the snapshot active. And that's pretty much what he's talking about, his issue with it.
What would you use to pause the initial
Um, you could, I mean, you have to add some like extra code in here to say like, are we like maybe you add a new method or something like is snapshot being activated?
Okay, sure.
Yeah, and then you do a check. Yeah, in that maybe net processing, and if you're still activating the snapshot, you're not going to send out any get block requests for the block, and you just like return.
So that would be in processing, you said? Or
In net processing.
net processing?
So
Is that a module?
it is the file we had here, net processing.cpp, send messages, and this is where we get data blocks. Yeah, see, we had background sync and process. We have things like this, so we maybe make a new thing that says is snapshot being activated. And he has pause IBD until the snapshot is loaded and the snapshot chain is activated. So that's his issue. So hopefully that makes sense in the context of what we're talking about. Maybe we could do another one. Mainnet readiness tracking. So there are some things I guess they want to do before background chain. Stop syncing non-snapshot chain from peers that are already connected. Okay. And yeah, there's some issues open. RPC fixes for missing values, mainnet params themselves. So this is the thing I was talking about, which I also have in the slideshow. Remember we said, are we gonna have this? What's the holdup? Well, we have a PR. Only 2 reviewers. Maybe you guys could go and ack it, say ack and test it, Yeah, load his code first and maybe run some tests, try it out, and then just say ack tested. This is the actual PR, so we can actually look at the actual PR. All he does is he adds something here. This is what you need to do if you wanted to run Assume UTXO. You add this in, you have to rebuild. So it's not really
That's
for...
the change?
Yeah, this is a change. At this
Take out
height,
one line
this
address,
specifically.
The height, serialized, and change transaction.
Yeah, and you can get this information once you actually dump your transaction output set.
So this is to put his hash into Bitcoin Core?
Yeah, so...
As opposed to like, you can already calculate it yourself, but there's not like a mechanism for, I guess, well, you can run your own, but yeah, anyway, I don't know if that's the
Yeah, I have my own like dumped state, which is how I got the output here. This is the last slide, by the way, but all the way up here, this was made from my Bitcoin node.
As of today.
As of today. So if you were to build Bitcoin Core with my information, then you can now load my Assume UTXO,
With that.
exactly, UTXO set.
Why is he trying to commit
With a
that?
file.
Why is he trying to commit that though?
Let's go back. Why is he trying to commit this?
Yeah.
So people can use Assume UTXO with his UTXO snapshot, which should be the same for
At a
everyone,
certain block
by the
height.
way. Yeah,
Okay.
at block height 840,000,
Okay.
which is like,
was.
it's not super outdated.
Okay.
I mean, he could probably update that now, but let's see, we're 840,
And we-
800,000, 846,000, 814.
And if
So-
that got merged, would then Assume UTXO be enabled as per what we were talking about before when you were saying it was sort of broken?
It's not broken. It's just it hasn't been like enabled for the average consumer.
Is that all that's needed?
Yeah,
Okay.
for that for snapshots at this specific height.
So if you want a different specific height, you just change it to whatever height.
You have to add it and build it yourself. And most people can't build Bitcoin Core, right? So it's
Yeah, it's not a trivial thing.
yeah, right? They haven't or they don't know how to. And code change like this just to bootstrap your node isn't feasible. But the Bitcoin Core team plans to add these snapshot heights that they validated themselves. Like Shores is a core contributor, so he wanted to add his own that he calculated, which he should be able to because we want to use the feature.
Also, runner-up from Hardcore Trivia tab, Shores.
Oh yeah, runner up. I made sure to mention, not the winner.
Runner-up.
Yeah. Yeah, winners are here. Yeah, right here.
All the Shores can come, and he's very welcome.
Yeah, you guys dox yourself. The FBI, I heard, goes and asks for information from Tabcom. So.
FBI's on it.
Yeah. Another one. This is for the UI. Once they do add source change, you want to make sure transactions aren't presented as confirmed in the UI if it's on assuming UTXO.
Nice.
So yeah, I can see the utility is showing transactions as unconfirmed in the GUI, blah 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 blah, and we kind of went over that in the slides. But yeah, that's pretty much what I wanted to show you guys all today. Hopefully you learned something, and it wasn't. And there's a lot of code. I just thought it was the best way to try and show everything. But that concludes
Yeah, I think
understanding
the
Bitcoin
code,
Source 14.
So far, this one, I think, it's the most sense of actually seeing how, not only what these things are doing once we understand it, but this is how it's happening. So, very well done, Dave. Thank you.
Yeah, thanks.
Yeah.
And again, I'll put this on YouTube, so if you want to look at the files and try and like read and follow what I'm saying, like at your pace, then feel free to do that, and I encourage it. So, yeah, on the stream.
Channel.
Yeah, thanks for coming.
Source.